All right, going through the fill in the blank page. An atom has 14 protons. What is the element? So it has 14 protons. We go back over here and find element 14. So the element is silicon. So you put Si, or you can write the whole word if you want to. How many neutrons are in boron 14? So this boron 14, that means that there are 14 protons and neutrons. If you go look at boron on the periodic table, though, it only has 5 protons. You can see it right there, 5. And so we have 14 minus 5. That gives you 9 neutrons. So that answer will be 9. Okay, and which one of the subatomic particles occupies the most space? Well, that would be the one, the space is this area occupied by the electron cloud. So this out here is the space in the atom. Okay, so that would be the electron. The neutral particles that the nucleus contains, remember the nucleus contains protons and neutrons. Which of those is neutral? Number 5, the positive particles. Well, if the neutrons are neutral, follows that the protons are positive. And the area outside the nucleus out here, that's negative, because the electrons have a negative charge. Okay, and if you have more electrons than protons, that means more negatives than positives. So, and then the mass, if you remember this notation we had like this, this was the mass number. And so the two particles that determined them were the protons and the neutrons. The subatomic particles that you expect to find in energy levels outside of the nucleus, energy levels out here, and then of course where's the mass all located? All right, and then orbitals outside the nucleus, same thing, same answer. Energy levels are divided into sublevels, sublevels are divided into orbitals. Electrons are outside there. Most involved in bonding. Now, for these, bonding means when the electrons connect with each other, or the atoms connect with each other. Since the electrons are on the outside, they're the ones that are going to be involved in interacting with other atoms because the electrons are on the outside of the atom. Remember, they're up over here on the outside. Identity, we already talked about that a few minutes ago in the previous video. Identity is determined by protons. Remember back in the atom building, every time I put a proton in, the identity of the atom changed. Let me see if I could just pop that up here real quick and show you. So if I did classwork for chemistry P1 here, and go down to the atom building activity. So if you look here, when I put protons in, the identity changes. The charge changes. The mass changes. When I put neutrons in, only the mass is changing. Watch it. So it goes to 6 down there. Now it's going to go to 7. If I put electrons in, only the charge changes. And when the electrons equal the protons, then the charge is 0. But if I lose an electron, then the charge goes up. Losing electrons makes the charge positive. Gaining electrons makes the charge negative. You can see it here. All right, so would a positive ion have lost an electron? The answer to that is yes. We just showed you that, and the charge on a proton is positive, and the charge on an electron is negative. So that's just a little review of basic atomic structure. Okay, notice it says read this. So atomic number is the number of protons, always. If the atom's neutral, the electrons are equal to the protons. If there's a positive charge, the atom has lost electrons, so the charge becomes positive. If there's a negative charge, the atom has gained electrons, so the charge is negative. And then, of course, protons plus neutrons equals the mass number. Notice it says assume there is no charge for these elements. So it's calcium 39. So that was the mass number, remember? 39. Okay. Okay, the number of protons for calcium, we don't know. We have to go back and look. So you click over to the periodic table, and calcium is over here on the left side, and its atomic number is 20. The atomic number is the number of protons, so it's 20. The number of electrons equals the protons if there's no charge, so that'll be 20 also. And then the protons plus the neutrons equals the mass. Okay, so remember mass, protons plus neutrons, so that minus the protons would give you the number of neutrons. And the element symbol is Ca. For this next one, you got 83 electrons. Since there's no charge, we're going to assume there's 83 protons, which means the atomic number is 83. So then we have to go look see what element 83 is. And it's right here. It's bismuth. So the symbol is Bi. The mass number, we know the neutrons and we know the protons, so we add 125 and 83. So you get 8, 10, carry 1, 208. All right, and then the hyphen notation for that would be bismuth, and then you just write the mass down. Okay, the atomic number of this next one is 14, so that means it's got 14 protons. So what element has 14 protons? Oops, I skipped that. I forgot to change back to the screen. So what reviewing bismuth real quick, we knew 83 electrons. So if 83 is the atomic as a number of protons, and that's the atomic number. Add the 83 and the 125, and we get 208, and that's the mass number. The symbol's bismuth, and then to write the hyphen notation down, you just hit bismuth and write down bismuth and hyphen 83, which is just, I made a mistake here. That should be bismuth 208. You write the mass number down, 208. Okay, so be sure you catch that. I'm not going to redo the video, so be sure you make that change. All right, so the mass number here is 27. The atomic number is 14, so you flip back over. Atomic number is 14, so that's silicon. So that's Si. And the number of electrons is equal to the number of protons if there's no charge, and it said there was no charge on these, so that would be 14. The mass number would be the protons plus the neutrons, so we aren't told what the neutrons are, but we're told the mass number. So this number plus, so 14 plus something has to equal 27. So that means that the number of neutrons have to be 13. So that would be 13 neutrons, and then the hyphen notation would be silicon, 27. So you write the mass down. All right, so that was that table. Now let's take a look at this table. Here we have 10 electrons with a +4 charge. Note that there are charges. They're ions. So this is a +4 charge. That means you've lost 4 electrons. So before you lost 4, how many did you have? You have 10. After you lost 4, how many did you have before you lost those 4? So it would have been 14. So that means when there's no charge, remember the protons equal the electrons? So in this case, when there was no charge, there were 14 electrons, so there would be 14 protons. We're told that the mass is 27, so that would be 13, because 27 minus 14 gives us 13. Mass number is 27, atomic number 14. That's the number of protons, element symbol, silicon. Okay, next one is 7 protons, so you got to see what element is 7 protons. Just click over here. 7 protons is nitrogen, so the symbol is N. The atomic number of nitrogen is the same as the number of protons, 7. The mass number is the protons plus the neutrons, so I told you 17 neutrons here. Wow. Okay, for 17 neutrons, that would be 24 for the mass number. So you would call this nitrogen 24, that's the mass. And the number of electrons equal the number of protons if there's no charge. But in this case, there is a charge. It's -3. So how many electrons would you have? Remember, if you gain electrons, what happens to charge? I think I wrote that down somewhere. I did. So gain of electrons equals negative charge. Okay, so that means you gain 3, so you're having 10. So normally you would have 7, but you've added 3, so that would give you 10. Okay, the atomic number of 57. So you look back over and see what 57 is. 54 must be over here. 55, 56, 57. It's lanthanum. It's La. All right, the mass number is 140. So I know that 57 plus something equals 140. So how do you solve for x? So take away the 57. So 10 minus 7 is 3. 13 minus 5 is 8. So you'd have 83 is the number of neutrons. Since the atomic number is 57, the protons are 57. The charge is plus 3. So has it lost or gained electrons? So positive charge means you've lost electrons, so that'd be 54. And because you lose 3 from our normal number of electrons, which was 57, because we would normally have the same as we have the protons. And then the hyphen notation is just the name of the element, lanthanum. Hyphen, we'll put it down here, the mass number, which is 140. Next one's atomic number 16. So you look at 16. Oh, shoot, I keep forgetting to go back to the screen. So let's run through lanthanum again. Okay, so lanthanum, we had 57. So I went back and showed you how I found 57. It's right here. Okay, so that means protons are 57. The mass is 140, so I put the hyphen notation lanthanum 140, because that's the mass. The electrons are going to be 54 because there's a plus 3 charge, so you've lost 3, so that makes 54. You had 57, but you've lost 3, so now it's 54. And the neutrons, you subtract to get the number of neutrons, so you take the mass number minus the number of protons, because this equals the protons and the neutrons all together. All right, now we're back to number 16. And number 16 is sulfur. It's right here. Right there, 16 sulfur. Look at that, I remember to go back. So sulfur. The atomic number is 16, so that means the protons are 16. The mass number, we don't know, but we know the neutrons are 20, it tells us, and we know the protons are 16, so that would be 36. Protons plus neutrons equals mass. The electrons equals the protons unless there's a charge. Oh, but there is a charge. So that's a negative charge. Does that mean you've lost or gained electrons? So you gained. So 16 protons would normally equal 16 electrons in a neutral atom. This is -2. I've gained 2 electrons, so that would be 18. And then the hyphen notation would be sulfur. Then you'd put the weight down. The weight is 36. So the mass number is 36. All right, I'll stop there on this video.